Today we'll be doing Chapter 17, Probability Models. A situation is called a Bernoulli trial if it meets the following criteria. 1, there is only 2 possible outcomes called success and failure for each trial. The probability of success, denoted with a P, is the same for every trial, and trials are independent. The 10% condition. If the trials are not independent, sample and without replacement, it is still okay to treat them as Bernoulli trials as long as the random sample is less than 10% of the population. P equals the probability of success, Q equals 1 minus P, the probability of failure. The probability density function, PDF, assigns a probability to each value of X. The cumulative density function, CDF, calculates the sum of the probabilities up to a value of X. The geometric model for Bernoulli trials is GEOM-P. Geometric random variable, X equals the number of trials required to obtain the first success. Because the number of trials is not fixed, there could be an infinite number of values for X. The probability that X is equal to N is given by the following formula. So the probability of X equals N equals 1 minus P to the N minus 1 times P, or Q to the N minus 1 times P. The expected value of a geometric random variable is 1 over P. And the standard deviation of a geometric random variable is the square root of Q over P squared. Let's look at this example here. Your car has a dead battery and you don't have a jumper cable. Suppose 25% of all cars carry jumper cables. How many cars will you need to stop until you find one with cables? A, are these Bernoulli trials? So that's the first thing we need to discuss here. So are there 2 outcomes? So there are 2 outcomes. Our success equals has jumper cables. Our failure has no cables. The probability of success is P equals 0.25 for each car stopped. Our trials are independent. One car having cables should not affect the chances the next car will have cables. So B, define the random variable and specify the model. So our random variable X will be the number of cars until one has cables. And this is geometric because it could go on forever. C, find the mean number of cars, the expected value you will need to stop. So my expected value of X would be 1 over P, which would be 1 over 0.25, which equals 4 cars. Find the standard deviation. So D, the standard deviation. So that equals the square root of Q over P squared, which would be the square root of 0.75 over 0.25 squared, which is about 3.46 cars. And then calculate the probability of the first success being on the first 5 trials, on one of the first 5 trials. So we're not gonna do this for each one. So the probability that it's on the first one is 0.25. So the probability x equals 2 would be, the first one was a miss, so that was 0.75, times the second one, 0.25. And that would give you 0.1875. So this would be 0.1875. And then I'll do one more, the probability that x equals 3. So that means the first and second, so the first and second car were not successes, but the third car was a success. And that would give us 0.1406. So that's how you continue it. The fourth one, so the probability of x equals 4 would be the first 3. So it would be 0.75 to the third, and then it would be on the fourth one. And then the probability of x equals 5. The first 4 were failures, and the last one was a success. And you can just put those into there. So on your calculator, you can actually use your calculator functions. We're not going to construct a correspondent histogram for this. You can do that on your own. But one thing I do want to talk about on your calculator is you have Geo, Met, PDF, and you'd put X and P in it. And that's the probability of success on the Xth trial. And then you have Geo, Met, CDF, and that's the probability of success on or before the Xth trial. So that's cumulative, where the other one is just the individual probabilities. Let's look at the binomial model for Bernoulli trials. So this would be binom N and P. So a binomial random variable is x equals the number of successes in n trials. There's a fixed number of trials or observations. The expected value is n times p. The standard deviation is the square root of n times p times q. Let's look at example 2. Suppose 10% of freshmen in college drop out during their first year. For 5 randomly selected freshmen, find the mean and standard deviation of the number of freshmen that drop out. So A, are these Bernoulli trials, and explain. So A, there are 2 outcomes. So yes, so we have 2 outcomes. Our success is a dropout, because that's what we're looking for. Our failure would be stay in college. The probability of success is 0.1 for each freshman. So the trials are not independent because the population is finite, but 5 is less than 10% of all freshmen in college. Okay, let's look at B. We need to define a random variable. So we're going to have let X equal the number of dropouts among 5 freshmen. So this would be a binom of 5, and our probability is 0.1. Find the expected value of X. That would be N times P, which equals 5 times 0.1, which is half a freshman. And the standard deviation of X is the square root of N times P times Q, which would equal the square root of 5 times 0.1 times 0.9, which equals about 0.671 freshmen. The binomial coefficient. In how many ways can we get 0 successes out of 5? List them. So call this 5, choose 0. There's only one way. In how many ways can we get 1 success out of 5? We're going to list them. We call this 5, choose 1. There are 5 different ways. And how can we get 2 successes out of 5? This is 5, choose 2. There are 10 different ways. There are 10 different ways to choose 5, choose 3. There are 5 for 5, choose 4. There's 1 for 5, choose 5. And the binomial coefficient is the number of ways to arrange k successes in n observations. It is written as n choose k. So we call that n choose k when you have in parentheses n over k. There's no division bar there. Each different order for our observations is called a combination, and you should remember this from your past math classes. The value of n choose k is given by the formula for combinations. N choose k equals n factorial all over k factorial times n minus k factorial. If X is a binomial random variable with parameters n and p, then the probability that X is equal to k is given by this following formula. Usually we use n choose k times p to the k and q to the n minus k. Let's look at example 3. For our previous group of 5 randomly selected freshmen, find the probability for each outcome. X equals the number of dropouts. So the probability that X equals 0 dropouts would be the probability of X equals 0, which equals 5, choose 0. So this would be 0.1 to the 0 times 0.9 to the 5th. And when you put that in your calculator, you would get 0.5904. 49. And the probability of X equals 1 would be 5, choose 1. We have 1 success and 4 failures. And this would be 0.32805. And we're going to do one more. The probability of X equals 2 would be 5, choose 2. So we would have 2 successes and 3 failures. What do you notice about the exponents? They add up to 5. And this one would be 0.0729. You can try to do 3, 4, and 5 on your own. The answers are 0.00081, 0.00045, and 0.00001. On your TI 83 plus, our binom PDF, you'd put N, P, and K in here. And this is the probability of K successes and N trials. Then you have your binom CDF. And this would be N, P, and K again. And this is the probability of K or fewer in N trials. K or fewer successes in N trials. We're not going to construct a histogram on here, but if you need to be shown how to do it on your graphing calculator, just ask me in class.